My name is Ben Trumbore. I'm a computational scientist at the Cornell's Center for Advanced Computing. And today we're talking about working with Excel files in Python and C#. And what I'm going to do today is first talk a bit about what you can expect to hear about in the talk and what you won't hear about. And then I want to give some background on Excel files, the different formats of Excel files and what's stored within them. And then we're going to go through a series of slides related to coding in C# to work with Excel files, and then the same sort of series for working with Python. I know some people may be more interested in Python than C#, but I encourage you to pay attention during the C# part because some of the things that we'll be discussing will be relevant in the Python section as well. So the goals for the talk are to help you understand what kind of functionality is available for writing code that interacts with Excel files. This is going to be medium to high level information, just so that you know what you could try to do. And in particular, we're going to talk about two different software packages, one for use in C# and one for use in Python. There are other packages. And of course, there's more details than I'll be able to talk about in this talk. But I'll try to point out some things that you need to think about before you begin a project that works with Excel files, because there are some factors that may play into your choice of language and the package that you use to do your coding. What I won't be able to do in this 1-hour talk is explain everything down to the last detail. I'll give code examples that should be pretty clear, and they'll give you the kind of examples you need to understand if you want to make your decisions about which package, which language to use. There's also features in these packages that I can't talk about today, which would be some of the fancier stuff you can do in an Excel file. You can put images and charts into Excel files, pivot tables and macros. I'm not talking about any of that today. Just the data that you put into the individual cells of an Excel workbook, worksheet. And I'm not going to be able to teach you how to program in either C# or Python. I'm assuming that you have some familiarity with programming in general, at least, or possibly with those two languages. The code examples are pretty simple and straightforward. You should be able to understand them even if you don't know either of these languages. And of course, I'm not going to be able to teach you how to use Excel. It's good to know how to use Excel if you want to program to modify Excel files, read them and write them, but it's probably not quite essential. So why would you want to work with Excel files from software? One reason is if you've got some external data that someone has given to you and you want to bring it into your analysis software or use it in your workflow in some way, a programmed workflow. You want to be able to load the file and get the data out of it. And on the other end of it, if you have either an experiment or some analysis software that is generating data, you might want to share it with others in a format that is easy for them to use. And so writing it out as an Excel file is desirable. It's a very portable way to hand data to someone, and it's also easy for them to just look at the data and even work with it in Excel itself to generate charts, for example, or add analysis to the data. And if you have data that either you've generated or someone else has given you and it's not quite in the right format, it needs to be cleaned up or rearranged in some way, you can do that programmatically. And this is especially useful if you use something that you need to do over and over again to a bunch of different Excel files. If you write a program to do it, you just run that program on each of those files instead of having to run Excel, load the file, and remember the 18 different steps that you want to perform and do them by hand. So it's a valuable skill, and it's not actually that hard to do. So what is in an Excel file? Well, an Excel file contains all the data necessary to represent one Excel workbook. Workbooks may contain multiple worksheets. Those are shown usually as tabs across the bottom of Excel. And then each worksheet is comprised of a bunch of cells. And familiarly, you'll understand that you can address the cells by the row and the column that they're in. You can also address entire columns and rows of cells and perform operations on them. A cell may have a static value in it, could be a number or a string or a date, or it could have an expression in it. Some people would call that a function. To me, expression is a better word because expressions can be made up of mathematical terms and calls to functions, like give me the absolute value of this number, for example. Another term I'd like to define is if you have a rectangular subset of the cells in a sheet, a worksheet, that's called a range. Sometimes you want to perform an operation just on that subset of the worksheet. Something you may not occur immediately, but it is possible to apply styles to the cells in a worksheet. And so they can be applied either to individual cells or to the groups of cells that we've just talked about, which would be a whole worksheet or a row or a column or some range, some rectangular subset of the worksheet. And when I say styles, I'm talking about things like specifying the font and its properties that are used to display the value of the cell, number formatting, the colors of the foreground and the background, applying borders, and some more stuff. So I'm going to talk a bit about how to apply styles through code, which is one of the things you can do to tidy up a file and make it look better. So over the years of existence of the software product, the Excel file format has changed a couple times. I'm not going to talk about the dark ages, but before Office 2007 came out, the files were of the type XLS. That was the extension on the file. And this was the proprietary Microsoft format. You couldn't see what was in the file. The only way to read it would be to load it into Excel. But with Office 2007, Microsoft added a new format called XLSX, which for some of you might be the only format you've ever seen. This is an XML-based format, and it's actually really it was a wonderful change. It opened up visibility of the data to people who want to write programs like we're going to talk about today. So some people may also think of CSV files as an Excel file. It's really not a formal Microsoft Excel format. CSV, as you may know, stands for comma separated value. It's a text file where you have numbers or strings separated by commas, and the space, the content between each of those commas represents the contents of one cell, and every line of the file is one row. So this is a very limited format. It can only represent one worksheet worth of data, not a whole workbook of multiple sheets. There's no styling in it. You can't include things like images and charts. And you have a bit of a problem if you want to put commas into the strings in your content, because they're the delimiters that separate the cells. So my advice, if you ever have a CSV file and you want to do some coding with it, is to first load it into Excel and save it as an XLSX file, the new modern format. So I'm not going to tell you today how to work with the old XLS files. There are packages that will let you read and modify those files through code, and I'll mention some of them. But really, it's the modern XLSX file format that is the way to go here. As with the CSV files, if you have an XLS file and you want to work with it in code, my recommendation would be to load it into Excel and save it out as an XLSX. Bring it to the modern world, and then load it into the program that you've written that modifies it or reads it. So what is an XLSX file? Well, it's essentially a zip file, an archive of other files and folders. And inside these folders are files, many of which are in an XML format. XML stands for Extensible Markup Language. It represents structured data. It's very easy for computer programs to parse this data. And so that, Microsoft differentiated XLS from XLSX by putting the extra X at the end of the file name. So if you have an XLSX file, you can actually open it with a program like WinZip or 7-Zip and see the contents of it. And I've done that, and I'm going to show you the contents of a sample file that I'll be using throughout the demonstrations today. So I opened an XLSX file with 7-Zip, and at the top level is the little directory listing you see at the top left. Got 3 folders and 1 XML file. Of particular interest to us is the folder named XL. If you look inside that folder, now we're starting to get to the contents of the workbook. So, in fact, let me show you what I'm looking at here. This workbook.xml file contains a listing of all the sheets that are in the workbook, the worksheets, and their names. The style file indicates definitions, that it contains definitions of the different styling that is applied to cells in the worksheets. This string file has all of the strings that are stored throughout the workbook. For efficiency, Excel stores every different string just once, and then they refer to it by an index. So you don't have to, if you have a string that's used many times, it doesn't take up a lot of space in the file. In particular, interest to us here is the worksheets folder. And if you go into that folder, there will be 1 XML file for each of the worksheets in the workbook. And we're going to take a look at some of these XML files, just so you understand what it is we're actually working with. I hope you can read this here. This is the XML content for the first sheet in the demonstration file that I'll be introducing in a bit. This is what the worksheet looks like over here. It's got 2 columns and 5 rows of data. The left column and the top of the right column are strings, and these 3 values here are static numbers, and this number here shown as an 18 is actually the result of an expression. So inside the XML file, there's some things that might be interesting to know. One is that the file knows the dimensions of the data within it. As you may know, that you can have infinitely many rows or columns in an Excel file, but once you've put some data into it, Excel can say, okay, the bounds of the data are, it starts in this column in this row, it goes in the upper left-hand corner, and it goes down to this other location, this other cell in the bottom right. There's no data outside of that rectangle. So Excel remembers that in the file. You may have, I don't know if you've ever wondered when you start up Excel, how does it remember where my cursor was, which cell I had selected the last time I was using this? And that's also stored here in this XML file. And then we get down into the sheet data section, and you'll see here that there are a row after row of data that says what's in the worksheet. And within each row, there's cells. That's the C element here. So in this first row here of the table, there's 2 cells. One is in cell A1 and the other cell A2, and their type is S string. And the value for those cells is 0 and 4. Well, that's kind of odd because we know it should be name and value. But if you come over to this little section I'm showing here, which was the strings XML file, sure enough, at index 0 in that file is the text name, and at index 4 is the text value. So that's how Excel is referencing the strings. If we go to the next row, you'll see the numbers 1 and 3 for the values. 1 is the index for the string A, and 3 is the actual value that is in that cell. We go all the way down to the last row here, to the last cell, this 18 that I talked about, B5, cell B5. Here you'll see there's 2 values. The value 18 is there, but also the expression that's used. I'm summing up the values of everything in cells B2 through B4. So Excel can re-execute this expression if any of those values change, and it will come up with a new number. But it's important to note here that it caches the value of the last calculated result from that expression. And when we look at the different packages, we'll see whether you can access both the function or the value that was the last calculated value. But it's important to know that it's cached in a file every time you use Excel and change something in it. It will save a cache value of the result of any expressions. So when Microsoft came out with this XLSX format, they also made available something called OpenXML, which is a software development kit, an SDK, for reading and writing these types of files, these XLSX files for Excel. It also lets you read DocX files for Word and PPTX files for PowerPoint, and I think a few other types. Essentially, everything in Office 2007 had a new data format that was XML based, and this software library would allow you to read and write them, which made it easy for people writing software to modify these files to get the contents out of them. For example, I'm not certain of this, but I'm pretty sure that Google Sheets is using the OpenXML SDK because it lets you import and export XLS files into Google Sheets. Same for Google Docs. So this is great, but as you might imagine, given all the things you could do with Excel, the software, there's got to be a lot of function calls and classes and things in this OpenXML code, and it could make it very cumbersome to try to sit down and write a program to modify an Excel file. And most application developers like you and me, we don't need that much detail. So what others have done is they've written packages that wrap this OpenXML functionality and just present you with a nice high-level interface that lets you load a file and change the value of a cell, do things in a simple format. And it's really only the most important functionality that is allowed through that wrapper. And we're going to be looking at one of those packages today. Now, I mentioned that it's a .NET package. Microsoft's .NET framework is the platform upon which a lot of their software is based. And so any package that wraps OpenXML's functionality is going to have to be a .NET package. So it's not going to necessarily run on Linux, for example. But there is another way that you could take advantage of this change to using the XLSX files, and that would be, since the data is stored in a publicized XML format, which we just looked at, you could write code that simply reads in those XML files, opens up the zip file, looks at the files you want, and reads in their content, and then a developer could write a program that allows access to that. And some of the packages we look at are probably written that way. In fact, one of the ones we see today for sure is written that way. It does not use OpenXML. It just uses the data format that underlies OpenXML. That's the Python the approach that was used for the Python code we'll look at today. All right, so a couple little things I should mention here that are not related to what I'm going to try to show you how to do. Before Office 2007, if you wanted to work with Excel files through code, you would need to use something called Microsoft's Excel Interoperability Library. Essentially, this was a library that would call an installed version of Excel to access the functionality within it. So your program would make calls to the interoperability library, and it would call Excel. This meant that you had to have Excel installed on the computer where you were running your program to work with Excel files, and it would actually fire it up and talk to it while your program was running. You might imagine that that was kind of slow. This only worked with the XLS files. It does not work with the newer XLSX files. I'm mentioning it here because if you go out and Google for editing XML files, Excel files from some programming language, you're likely to run into some hits, some results that talk about the interoperability library. And I want you to understand that this is the old school way of doing it. I don't recommend it. Just look for results that talk about XLSX files. So be on your guard if you go out and Google. And I should say, as I mentioned, I'm not giving you every last detail of information today. So you're probably going to need to do some searching just to learn the last bit of what you need to know to make this kind of software work. And one other sidebar here. So we've talked about this a bit already. In a cell, you can have an expression rather than a static value, and the expression can call functions. And we've seen how the XLSX file caches the last calculated value from an expression. And as I mentioned, the software we're going to use, the packages we're going to look at today, can get to either the function, the expression that was stored in the cell, or the last calculated value. But these packages, beyond reading those values out, may not do so well when working with these functions. If you have an expression that references a value in another cell, and that value changes, you would like the expression to reevaluate itself. Some packages will reevaluate it, and some won't. When you save the file out as an Excel file and then open it in Excel, Excel will recalculate the value for you. But live within your program, if you've got expressions, you need to know whether they're going to be updated and maintained correctly or not. We'll see instances today when they are maintained, and we'll see an instance where it's not. So if the application you would like to write does not require the use of expressions, then you don't need to worry about this. But if you think you may be opening files that have expressions, or you want to add expressions to files and have them calculate values for you, you need to keep this in mind. And even if a package does handle expressions well, expressions can call a bunch of different functions. There are literally hundreds of functions in Excel, and some of them are pretty esoteric. So not all packages will implement every last function. I'll talk a bit about which package. The first package we look at does do a nice job of handling all the important functions. So I think I made a mistake here. Okay, these are the paths of data flowing that we're going to talk about today. The blue rectangles in the top are the C# example, and then the lower orange ones are the Python example. So if you write code that loads in an XLSX file, it will be parsed and stored in a format that is defined by the package. So for C#, the package that we're going to be talking about is called closed XML. It's sort of a play on the name OpenXML, which was Microsoft's library for reading the files. And then you can get values out of the cells and use them in your code, or you could put values into the cells and they will be stored in the data structure of closed XML, and then when you ask it to write out the file, they'll wind up out of the file. So that's a way you can operate on cell by cell. You can change the read or change the content of the XML file. This closed XML package also provides the ability to take a data table object, which is from .NET, Microsoft's .NET. It's an object, it's a class that they've defined that stores a table's worth of data. You can just pass in a table object, and it will get put into closed XML and saved to the file. So that's a convenience function, and it is quite convenient if you're working with SQL Server databases. When you're using C# code and you get data back from a SQL Server, from a query to a SQL Server, it's usually in this data table format. So you just get that and just pass it right in as a whole new worksheet, and you have to write very little code to get that data into an Excel file. So a very similar thing in Python. There, the package we're talking about will be called OpenPyXL. And it can also let you read from and write to individual cells in the worksheet. But it also has an integration with pandas, the data frame class of pandas. This arrow here should be both directions, and it should be green. You can read the data from a worksheet into a pandas data frame, and you can write back into a worksheet from a pandas data frame. And so that can make it easy if you're doing analysis, or if your code is generating the pandas data frames, then it's quite easy to get that content into an Excel file or read it from an Excel file. Okay, I'm about to start talking about C#. Chris, do we have any questions?
Not at this point, no.
Okay, please feel free to write into the chat if you have any questions. So closed XML is the library that we'll be talking about. It's based on OpenXML. It's free. I've used it from C#. It is a .NET library, so you might be able to use it from Visual Basic or from C++ in the .NET environment. It's a very mature package. It's very efficient, fast. I've used it a lot, and I highly recommend it. So when you get the slides for the talk, you'll have these links to the documentation for it, and it's open source. So if you want to look at the code, they also have a wiki with some nice examples. This is how you perform this workflow, and so it's more than just a little reference section. It's actually a little application. There's a apparently very similar product called IronXL. In my view, it's quite expensive. It could be very good. I haven't tried it. Can't speak to it. So if you want to use closed XML, if you're using Visual Studio, you can install it into your project with the NuGet package manager. If you're not familiar with NuGet, you should probably Google that and learn about it. But it's a nice mechanism for finding software that has been registered with Microsoft for use in Visual Studio, and it'll load the package for you and help you update it and so forth. But just look for closed XML when you're in the NuGet package manager. And you can use the NuGet package manager if you're using Visual Studio Code, although it's not quite as straightforward. Now, while code runs on Windows, Mac, and Linux, I'm not sure actually if they all allow you to install C#. C# is not installed by default with Visual Studio Code, nor is the NuGet package manager. So those are two extensions you'll have to add to your code installation. And then you need to create a .NET project, which was something I didn't understand. It's not just a bunch of files that are code you can run. You actually have to formally say, this package, this bunch of files here, going to be a .NET project. This link will tell you how to do that. Then once you've got your project, you can start the NuGet extension and search for closed XML and add it to that project. Okay. So we're going to talk about some of the different things you might want to do in code with an Excel file. And I have this sample file here, which is depicted at the top here. We've already seen this first page. The workbook, the sample workbook, has 3 worksheets in it. There's nothing in the second or the third one, but I gave them names so that we could take a look at how to find them. So the first thing you're going to want to do is open up that file and get back a workbook object. Pretty easy to do. Of course, if the file isn't found, there could be errors or so forth. So you'll need to handle things like that. I am assuming in all this code that those problems won't turn up. If you don't know what's in the file and you'd just like to learn a bit about it, one of the things you'll probably want to start with is looking at each worksheet in the workbook. So the workbook has a collection of worksheets, and you can iterate over it. And I'm doing that here, and then I'm printing out each worksheet's name. So that's this output here. Another thing you might want to do if you do know the format, the layout of the Excel file, is you might want to go to the first or second worksheet that's within it. Worksheets are indexed from starting with 0. So in this little bit of code here, I'm going to index 1, which is the second sheet. First, I'm doing a little range checking here to make sure that the workbook has that many worksheets. And then I simply say, get me from the worksheets collection, get me the one that's at position 1. And I print out its name, and sure enough, it's the second worksheet. And another way you might want to access worksheets is by their name. If you know the text that is used as their name, then you can say, from the worksheets collection, try to get worksheet with this name. And if you find it, or if you don't find it, return it as this variable. If it's not found, this value will be null. Otherwise, it will be the worksheet object. So I'm checking here to make sure that was successful, and then printing out the name, the fact that I found that third sheet. So it's not that hard to find your way around from the workbook down to the worksheets. And then once you have a worksheet, what might you want to do with that? Well, we're going to want to access the different cells, or possibly whole rows or columns or ranges of the data. So this example starts, we're just going to be looking at the first sheet, which is the one that where I put data into it. And the first 2 lines of code here are the opening the file and finding that first worksheet. Now, let's say you want to get the value from a cell. There's 2 ways to specify the cell whose value you want. From the worksheet, the cell function will find a cell, and it will either take one parameter, which is the string name of the cell, which is the same kind of name that you used in expression in Excel. So B3 is referring to this cell here, column B, row 3. Or you could specify the row and the column values in that cell function. And you'll see here that both of those lines of code return the same result. It found the cell with the 6 in it. But sometimes you want to iterate over a range of cells, either just in a row or a column, or over a rectangular section. So this rows function of the worksheet will return the list of rows that are known to have data in it. Remember that range information that we looked at in the XML file? This is just going to be the rows that are within that range, the places where there really is data. And then within each row, we can iterate it over all the cells that are in that row. And then I'm going to print those values out, the values of those cells. And sure enough, these 5 lines here very much equal the values that were in the worksheet. So that's how you would iterate over some part of the worksheet. If this is a place where I would say, if you're going to write a program that works with an Excel file, it really is helpful to know exactly how the data is laid out in that worksheet. It's going to be very hard to sort of snoop around in the code and say, where does the data start? Or, which string values represent the headers? I don't want to read those in as if they're numbers and so forth. If you are working with someone and they're giving you data through an Excel file, you really need to come to a formal understanding with them of what the exact specification of that file is. So they write it out the same way every time, and you read it in the same way every time. And I should note that they could be you. If you're generating data with one hand and reading it with the other hand, you need to formalize the way you're making that transfer. Now, one of the cells in this table, as we talked about, cell B5, is an expression. So let's look at how closed XML deals with that. If I reference cell 5, it has a property in it called has formula. And if that's true, then you can use this formula A1 property to find out that formula. So this line of code is true. I wind up printing out here the contents of the formula A1 property, which is different from the value property, which we thought was 18. And sure enough, the formula is the sum of the cells B2 through B4. So closed XML makes it very easy to tell whether a cell has a formula in it. And you can get to the formulas or the values at the same time. And here's another way you can iterate over some cells, and I just want to see if I can step through this. So I asked for a specific range of cells in the worksheet from A2 to B4. These were just this is just the rows here that have the actual data, not the header, not the totaling thing. And then I can find out from that range some things like the first column, the last column, first row, last row. I could do iterating over it, but here I'm asking for the last column. So when I say last column, I wind up with another object called a range column, and I can iterate over the cells in that range column. And then I'm going to look at those cells, and what I'm trying to show here is that the cells have knowledge of where they are in the worksheet. They know which worksheet row they're in, and the worksheet row knows what number it is within the worksheet. So I'm printing out here that row 2 of the range was actually row 3 of the worksheet. I think I've printed something wrong there, but my point with this bit of code was that you don't have to drill down from the top necessarily in all cases. If you've got a cell, you can find out where you are in the worksheet. Okay, so that's 2 examples of reading data from a file. I'm going to turn it around now and look at creating Excel files. The first example here merely creates a workbook with 3 worksheets in it. So in the previous example, we created our workbook by reading it from a file. Here we're just going to instantiate it. I'm not even giving it a file name yet. Then I can add a worksheet to it. If you just give a name for that worksheet, it will be placed at the end of the set of worksheets. And there were initially none in this workbook. So that, at this moment, after this call here, we just have one worksheet in the workbook, as it would be called edit first. If you do specify an index, then your worksheet that's being created will be inserted at that location. So here I'm inserting a new worksheet at 0, and that pushes the one that was added first over to the right. And then, as I was mentioning earlier, if you have a data table, so here I'm creating a fake data table object. Let's pretend it came from a SQL Server query. I can just say add worksheet from that data table. That easy. Boom. I get a new sheet over here, and whatever was in that data table gets put into the worksheet. And now I can save this workbook object as a file. Just need to give a name to it. So I'm using the save as command to specify the name. If you've saved this file already, then there's a save method that will use the existing name. Or if you have loaded the file from disk and modified it, and then you can just call save, and it will save it back out over that same file. Well, if you're going to create a file, you're probably going to want to modify its contents. And this is true whether you've loaded the file from an existing Excel file, or if it's something new that you're creating. So once again, we get a workbook. It's this one we've been using, this example test.xlsx, and I get the first sheet from it. And I want to change the value of cell B4. I'm going to set it to 12. And that's what this line of code does. So this B4 is the cell that had a 9 in it before. And I'm changing that to a 12. And then I'm going to say, okay, show me the value. And sure enough, right away, I get the new value from the cell. That's not magic. You would expect that to happen. But it's for static values that you would expect that, but it's interesting to know whether if you change some cells, whether formulas will change the expression. I'm going to change the value of cell B5, which was used to be the sum of cells B2 through B4. And I'm going to change it to now be a call to the function average. It's going to be the average of the cells B2 through B4. So I set that function, and I get that formula value back, and I see, yes, what I just said I wanted to do is what has been done. That formula has been changed. And then I ask for the value, and now I get the value 7, which is, if you add up 3, 6, 12, you get 21, divided by those 3 is 7. So in fact, the new formula has already resulted in a recalculated cached value that I'm able to see here in my program. Another thing you can do to a worksheet, something you probably would be more inclined to do is something that you've loaded in rather than something that you are creating. But you can insert rows or columns, and you can delete rows or columns. So I'm going to call the insert row below function here. I'm going to go to row 4, which was this one with a C in it, and I'm going to insert one row below that. So that's going to put a space between the row with the C and the row with the word total. Then I'm going to select column 1, and I'm going to delete it. So that's going to get rid of what had been column A. And now that I've done that, some cells have moved around. And the cell that had our formula in it is no longer in column B. Now it's over in column A. And in fact, it's been pushed down one row. So I'm going to go now to cell A6 and see what its formula is. And in fact, it has been modified by OpenXML in light of the deletion and insertion of columns and rows. I think that's wonderful. This is what you would expect if you were working in Excel. Excel updates formulas for you, expressions. And so closed XML does that as well. And in fact, you can see here then when we write out the file, this is what it looks like now with the added row and the deleted column and the changed function. The cached value of 7 is there. So to me, there's nothing lacking here. I could do everything I wanted, just as if I was within Excel. Okay, and one more example for closed XML, and this is working with styles. And then after this, we'll talk about Python. So once again, I'm loading in the first sheet of the workbook from our test. This is an example of what it looks like again. Forget about what we just saw in the previous screen where we changed the function and rearranged things. We're going back to the test example. At many different levels here, the worksheet level, the row and column, range, and cell levels, there's a style property. And we're going to set values in that style for each of them and see what happens. And as I mentioned earlier, style includes many things. It includes the font that's being used and the properties of that font. It could have to do with number formatting or colors or borders. So what I'm doing here at the worksheet level is I'm setting the font to be Courier New. So you'll see this is Arial or something in the original, and down here, if you can see, every cell has been changed to be Courier New, and that's really what happens. This information is being applied. This assignment is being applied to every cell in the worksheet. Similarly, if you select row 1 and get its style, and then within the style, the font object, you could change whether it's bold or not. And I'm saying, yes, make the first row bold, and the second column, make it italic. So you'll see here that the first row of the result is bold in all cells, and the second column is italic in all cells. And so that means that both of those property changes have an effect here in cell B1. This is good. This is kind of what you'd expect. That's how it would work in Excel. I'm applying here a number format to a range. I define a range of B2 through B5. Those are all the cells that have numbers in them. And I'm saying I want to show one digit to the right of the decimal point. And that's what we get. And then finally, I'm messing around with this the cell here that has the sum in it. Um, in the style, I'm changing the border to say that the top border should have thickness medium, and that's this black line here, and that the fill part of the style should have a background color of medium purple, and that's what you see. So I find that to be very easy and very clear, and I think it's actually worth a little extra time. If you're going to the trouble of writing a program, you might as well tidy up your data. I think make something stand out, in my opinion. This last section here, it might not be styles. You'll see that we're not calling a style property, but I think it has to do with the look of the file. I don't know if you've ever used Excel and typed a long text string into a cell and had it disappear after the right edge of the cell because the column wasn't wide enough. One thing I like to do if I'm pushing some data into some cells is to make the columns wide enough to fit the data. Now, you might know how wide you want the column to be. And if that's true, you go to the worksheet, you get the column you want, and you set its width to be some number. I must admit I don't exactly know what that number is, if it's like some number of characters or whatever. But here in column 1, I've set the width to be 15, and that's what I got. But it has another function which is adjust to contents, and it's implied that it's adjusting the width. So actually, before I call that, I'm setting this cell B6 down here to have this long text string in it, and then I call adjust to contents on column 2, column B, and it calculated that the column should be that wide to show all the contents. I love that. So when I wrote the file out, this is what it looked like when I opened it in Excel. So I can recommend closed XML, sorry, for working with Excel files in C# without reservation. Any questions about the C# part of this? If not, I'll go on to the Python stuff, which is going to be very similar. So for Python, we're going to be using the OpenPyXL package. It's also free. It's been around for quite a while. It's not quite as featureful as closed XML, and we'll talk about the areas in which it doesn't do the same thing. If you don't need those features, that's not a problem. I should say, actually, something I haven't mentioned, both closed XML and OpenPyXL can work with images and pivot tables, I think, and charts. They can do some of the things that I said I wasn't going to talk about. So if you have the desire to generate fancier or more complete Excel files, check the documentation. They may be able to do what you want. So the OpenPyXL has good documentation for it. There's a very expensive alternative called Excel Wings. That their pro version costs money, and there's also a free version, but this is like a sort of a legacy package that only works with the XLS files of years gone by. So I'm not going to talk about them here, but if you are Googling for Python XL, you're going to see Excel Wings mentioned, as well as some of these other packages. XLS Writer is another package that seems to be pretty good. As its name implies, it is a writer. It will write out XLS files, and it's integrated well with Pandas. So you could say, take this Pandas data frame and write it out in a file. It does not read XLS files, just writes them. So if that's all you need, and you like to work with Pandas, then by all means, go take a look at it. It seems to be quite popular. Pandas has a little access for reading and writing files. Sometimes it can only read the XLS files. It allows you to specify which file writer you want to use when you're writing. And the two options that I'm aware of are XLS Writer, which I think is the default, and the OpenPyXL that we're about to talk about. So in my view, you don't really need to limit yourself to what Pandas gives you there, what it is integrated with. You might as well learn how to use these writers and readers themselves. So I would recommend that you don't focus just on what does Pandas let me do. Like um, learn how to use one of these other packages. Some older packages that you may see if you're Googling is XLRD and XLWT. These only work with the XLS files, the ancient ones. So I would steer you away from those. It's easy to install OpenPyXL with a pip install command. If you want to have images in the Excel files that you work with, you'll also need to install the pillow package. Okay, we're going to go through the same 5 code samples that we used with the C#. Pretty, not quite exactly the same, but very close. So here we're loading a workbook from the test file. And just like we did before, you can iterate over all the worksheets in the workbook. And I'm printing out their names. Outputs very much like in the C# example. Or if you know the integer index of the worksheet that you're interested in, you can make sure that the workbook has that many worksheets, and then you can just access it. Oh, I'm sorry, I should have used the variable index there. That's what I meant to do. But when we get that worksheet, we can print its title out, and it's the one titled second. And then the third way to access worksheets is by using their name. And so here it's a little easier to say if the workbook has a sheet of that name. The workbooks here in OpenPyXL are actually like dictionaries. So we're gonna say workbook with key name, where name is third, and it will return the worksheet associated with that key. So you can ask more simply here, is that key in the workbook? And it is, so that's good. And here's a little example of working with a data frame. So this PD here is Pandas. Pandas will let you create a data frame from the values in an OpenPyXL worksheet. So we get the first worksheet from the workbook. We ask for its values, which are all the contents in the cells. And I'm going to print that out. There they are. And Pandas has added columns and row headers for it. It didn't know that we sort of had them already. You may be able to tell. There's maybe a way to specify that, but so it gave them 0 indexes for the rows and the columns. I'm not a Pandas person, so if you are, then this probably makes a lot more sense to you. But I think there's more control over that available here in this data frame constructor. Okay, so if we've read in a workbook and we can get to one of the worksheets, let's get to the first worksheet here. We're going to modify it just like we did in the C# example. So the worksheets are also dictionaries where if you give a cell ID as the key, then you will have access to that cell object. You can take its value. Alternatively, there's a function called cell on the worksheet that will let you specify a row and column index, and then you can get the value. So these two lines, as expected, produce the same result, which is the value from cell B3. You can iterate over a range of cells. The worksheets provide an iterator that will return all of the rows or all of the columns. There's an iter_col iterator as well. And then from that row or that column, you can iterate over all the cells. So here I'm iterating over every row, and in every row, I'm iterating over every cell, and I'm printing out its value. And sure enough, it's exactly what is it exactly what we expected? What about down here? The Excel file shows 18, but what we're getting here as the value is the expression that was stored there, which isn't really what I thought I would get. So this is a big difference between OpenPyXL and the closed XML. When you load a workbook, it's going to treat all of the stored values as the value of the cell, whether they're a function or not. If you would like to only work with data values, you can pass an additional parameter in to that load workbook method, and that's the data only parameter. If you set that to true, it will return then either the static value of the cells, or it will evaluate the expression. It will return it won't evaluate the expression. It will return the cached value of the expression. So in this line here, I'm saying I'm reloading a workbook 2 from that same Excel file. And then I'm going to the first worksheet, and I'm going to that cell B5, and now I'm saying, give me the value. The very same call that I used before, value, but this time I'm getting the 18, the cached value, because in this workbook, I said I wanted to only work with data. So this is a limitation. It's not the only limitation you'll see here, but OpenPyXL is not as featureful as closed XML when working with expressions. One more iteration here. We used worksheet iter rows before over here to look at all of the rows that the worksheet knew it had in it, all the cells that it knew were active. You could actually specify your own limitations. You can say, in this case, I only want to go from column 1 to column 2, from row 2 to 4, which are these sections here that have just the actual data. So that's what you see down here. When I iterate over those rows and columns, I'm just getting the subset that I want. And now the 3 pages for creating or modifying a worksheet. So we open a workbook. No, I'm sorry, we don't open a workbook. We're creating a new one. So I just instantiate a workbook object. OpenPyXL is a little different than closed XML. It actually creates one worksheet in your new workbook. It has, though, an active property in the workbook, which is saying which worksheet is active. So I use that to find the first already existing worksheet, and then I give it a new title. I don't actually know what the title was before. It might have been sheet 1, which is, I think, what Excel does for you. So after these 3 lines of code, I have a workbook with one sheet in it, and its name is default page. And then you can create more sheets, giving them a name, and inserting them, optionally inserting them with the index parameters. So here I've pushed in a new sheet in the first position, and it pushed over the default page. And I have 2 different examples here of taking a pandas data frame and putting it into a worksheet. So here I'm going to define a simple data frame. It's got 2 columns, one with the header names and one with the header values, and 3 values in each. And when I assign this into the sheet, the worksheet, I'm going to use this data frame to rows function, which is part of OpenPyXL. It's a utility function that knows it's going to be getting a data frame, and it will return a sequence of rows. And then you can append those rows to the worksheet. And at first I thought, well, this is unnecessary. I liked what closed XML did with the data table object. I just pass in the whole data table. Why can't I pass in a whole data frame? But upon thinking about it, it's actually more flexible. It's not a whole lot more code to iterate over these rows, but maybe you don't want all the rows, or maybe you want to put them in different places in the same sheet. You have that flexibility here. If you've got multiple data frames, you can put rows from each of them into the same sheet. Whereas in closed XML, it was just this data table becomes that sheet, and then you're done. So what did we get here? Well, we got our little 2x3, or was it 3x2 table, but we also got this row with headers the columns and another row with made up headers of the rows, because we never specified those. It turns out that that those get generated by the, I think by the utility function. And so if you don't want those, you have some options. You could turn off either the row or the column headers. And I'm turning them both off in this example, and I'm using the other data sheet. I'm just filling in a second data sheet with the same loop through all the rows of appending the rows. And here's just the data that I want to do. So this utility function does give you some flexibility of how you convert your pandas data frame into data that gets inserted into your worksheet. Now we're going to modify, we'll go back to the original worksheet, going to load the test file, find the first worksheet. We're going to do some of the modifications we did with the closed XML example. We're going to set cell B4 to B12, used to be 9, now it's 12. And when we print out that value, yes, that got assigned correctly. Now we're going to change the function in cell B5 from sum of these cells to average of these cells. And when we ask for that value, we see, yes, it has done that. Now remember, we've loaded this workbook without the data only parameter. So I want to see that expression has been changed when I wrote the cell. So that's correct. And then I do a similar thing here where I insert a row. These functions aren't as flexible as they were in closed XML. You can only insert before the current location. So I selected row 5 and I inserted one row before it, and that puts in this row here. And then I select column 1 and delete one column. So I'm able to insert rows and delete columns as before. Now I want to see what happened to that expression that I had put into cell B5 now that it's been moved to B6. So I ask for that value and I find out, oh, it's the same. It did not get converted to reference the new locations of the cells that it used to be working with. So this is another limitation of OpenPyXL with regard to expressions. It's just treating it as text. It's not recalculating anything, not moving cell references. So caution to you if you wanted to work with functions with OpenPyXL. I'm not saying it's bad. It just doesn't do this for you. And in fact, so then when you write this file out and open it up in Excel, this divide by 0 is because it's trying to calculate an average of these values, and there are no values, so that's the 0 that is being divided there. And OpenPyXL is a little different with regard to setting styles than closed XML was. So we have to import quite a few more things here because there's a styles section and every different thing, fonts and borders and fills are all in their own area. I'm going to load the same example file, find that first worksheet. Now they don't have, the OpenPyXL does not provide a way to assign some style values to a whole column or row or a range or a whole sheet. In all those cases, you've got to do some iteration. So I'm doing the same things we did before. This worksheet index 1 is getting row 1 from the worksheet. So I'm going to iterate over all the cells in row 1, and I'm going to set their fonts to be a new font that is bold. What I really wanted to do was just to take the existing font and set its bold property to be true, but OpenPyXL won't let you do that. This is a fixed, this is a read-only value. So this is unfortunate. You know, not being able to assign things at the level of a row or a column is not the end of the world. You can do the iteration easily enough. But this I found to be quite annoying, because now when I come along and I go to column B and I set the fonts to be italic, I'm overwriting something that I've already done. If you come over here, you'll see that I got the bold I wanted here in cell A1, But in cell B1, that boldness was forgotten when I wrote the italic value over it. So that's unfortunate. Now the italics should have been applied to this entire column, but as you'll see in this next section here, I'm applying a new style in cell B2, so the italics were lost. And this text value, you may remember from the other example, doesn't get added till later. So at the moment, that's not part of the range of the table of the worksheet that is considered active. So the style was not applied to that cell either. So you might be able to work around some of these things, and maybe for most applications, getting fancy with the styles is not that important. I'm just trying to make sure people know the kinds of limitations you might find in this package or in others that you may encounter. So this problem here of having not being able to reassign properties to style can be resolved in some ways by creating a named style. So here I'm creating a named style. I'm calling it number format, and in this constructor here, you could set a lot of different style things. I'm only setting the number format to be 0.0 for single precision after the decimal. And then you can assign to the style of any cell that name style object. And if you ever go back and change the name style object, the cells that used it will be updated. So here's the 3.0 value using the number format I specified. And that's why I had overwritten the italic that had been there before. If you have both a regular style and a named style, I'm sorry, if you've set some of the style properties in a cell and then you give it a name style, the name style takes precedence. It will ignore all the other things. So the italic that I set here before is ignored, and only the name style that I created is used. That's okay. I'm not upset about that. I was able to create a border and assign it to the cell B5's border, and the same with the fill pattern. It's a little wordy here. I mean, it's set up to let you do a color ramp, I guess it is. You could have different patterns. I just wanted a solid background color. I could do it. So that looks pretty much the same as before. And then in the area of setting the column widths, you can set the width. Once again, I use 15. Seems to have the same meaning here as it did in closed XML. I suppose that meaning is actually interpreted is the interpretation that Excel itself gives. And one of the reasons I think that this 15 is like the number of characters is if you want to make a column have about the right width to hold the data that's in it, you can just take the string length in characters of one of the cells, or the longest string of all the cells in the column. I happen to know that it was this cell B6 that was the one that was going to be the longest. So I got its string, calculated its length, and used that as the width value. And I got a reasonable column width that allows that whole string to be shown. So the styling has limitations, but I don't think it's awful. Certainly for most applications, it would be fine. Okay, we're just about done. I want to make a point here. I've talked about C# and Python, but there are many other coding languages, and for a lot of them, you will be able to find some kind of library package that lets you work with Excel files. And some of these are more mature than others. Some of them are more featureful. You'll have to investigate that yourself. For Java, I saw that Apache POI is mentioned quite a few times. Apache being a good organization, I would expect that to be a pretty good package. For C#, C++, I saw libxl and OpenXLSX packages mentioned several times. And for JavaScript, Microsoft has an API, and it's coming from Microsoft. I would expect it to be pretty robust. And I'm not sure exactly what their target audience is there, but it could be people who want to work with web-based Excel presentations. I don't know. But if you want to work with those languages to do something with Excel, it's worth a search and some testing.